this tutorial will be a before and after type tutorial. And so last time we went through the process of creating a route. So now we're gonna start as though we have a route, and we're going to create a before and after. And so the story here that we're going to show is one that we've talked about a couple of times. Our friend Chris O'Neill from CDTC brought it up a couple of times in this group. It's the Rexford Bridge, which is connecting Schenectady and I think it's Saratoga counties. So it's the north side of Schenectady County. There's a bridge that was undersized that they changed the flow, the traffic pattern, put a roundabout in before the bridge, and increased the capacity. And so what we're going to do here is build a report. So actually, I should slow down and show you where we started here, which is we click on reports, and we can click on new report. This is going to give us a blank screen that we're going to build this entire thing from scratch. There's other ways to do this, like we do have templates, etc., that you can pick from and start with that already have things loaded into them, graphs and everything's all set up. But I think for this purpose, it's good to show you how much capacity we have to change the data parameters and how to add graphs, etc. So first thing we're going to do is we're going to bring our route in, and so we're going to pick the Rexford Bridge. Why don't we try Rexford Bridge northbound here? And just to double check that we've got the one we're looking for, we're going to add a route map. So if you click on this graphs thing here, this is where you enter all your graphs into the picture. We're picking route map here, so we can see that this is the Rexford Bridge, and we're going to continue working with this here by let's add a route line graph in here across a day. This is an average day. This is how it loads immediately, right? So this is an average day. Right now we don't quite know exactly what we're looking at for an average day, so we're gonna jump into the data parameters to take a closer look. So when you click on your route, which is here, we can see a little bit about what we're looking at. So we're looking at the year 2020. So this is all of the data in the year 2020, all of the months. It's initially set up to take all of that data and collapse it into an average day. So every single data point at 12:15 has been averaged together to make our result of 34.26 miles per hour at 12:15. So every single time that we have any data for 12:15, it's been averaged together in 2020, right? So we can start here. One of the things I'm going to do is show you a neat little thing that's useful for tracking your routes. So if you give these squiggly brackets here, and you write year, and then you write name, year name, and this is something that we may ultimately default into the tool here. This gives you the ability to see what year you're looking at in your route list. So this is going to be super helpful in the next couple of steps as we add more routes to this comparison. So the next thing to do is add more routes, and we're going to change the year of each one of these things. So we're going to do this again here. We're going to change this to 2019, and we're going to update, and we're going to try that. We're going to do this a couple of times. We're going to change this to 2018 and update, bring in another one, 2017, update. And this gives us a number of different routes to look at, right? So, it's the same route. It's giving us a number of different years of data to compare, right? So this is, now we are comparing 2016, 2017, 2018, 2019, and 2020. And I'm actually going to drop 2020 off of here because we all know that 2020 is a year that with performance like no other, and probably no other will ever perform like that again. So we're going to call that one not part of this report. This is showing right out of the gate that there's a very big difference between a normal day in 2016 and 2017 versus 2018 and 2019. And so we're able to see that the way that this route performed changed drastically, and it's clear that the construction project, which happened sometime, we'll figure out exactly the date of when the final thing was launched in a few seconds here, but sometime between 2017 and 2018, we have a change in the way that this transportation network was working, right? So I'm just going to start moving these around. So these graphs are all like totally movable. I'm sure folks know that, but if you don't already, this is kind of part of a nice setup here. We're going to also add another one of these just so we can see other data. So so I just copied this graph, right? So we're looking at the same graph, but I want to change what we're looking at. So I want to see this from the perspective of hours of delay at this point, right? So now we're seeing what the average day in terms of delay looks like. So hours of delay are based on the Fed measure, the TED measure. There's a threshold speed, and all travel below that threshold speed picks up time and delay calculation based on that, the difference in the speed from threshold and the amount of time spent below that threshold. So that's now showing up here. I'm also going to copy this so we can get a little bit more context on what we're looking at here. So I'm going to zoom out. We're going to sort of see where we are in the region with this map, and this is more of like a close-up of where we're at. So actually, let's change this top one to travel time too. Travel time and speed are a function of distance. So the length of these two segments is the only real difference between looking at this as travel time versus looking at this at speed. When we're looking at hours of delay and travel time, it's more correlated. As you can see here, the yellow and orange are on top here, and they basically follow the same path or the same pattern as the hours of delay. So it's just, the difference here is when we look at it from speed, it's sort of, the graph looks upside down in comparison. So just changing that so that it just gives us a better idea of like what we're, how to compare these visualizations. So this is travel time, and we can change the names of these. This is going to show hours of delay. And this is total hours of delay, I believe, right now. We can also show average hours of delay, which just changes the axis over here a little bit. But it's more like, so this is showing your average travel time at this time. This is now showing your average hours of delay at this time, as opposed to when we had it as just hours of delay. What it was showing you was your total over the year at that time. So this is, total of 10 hours of delay across 2019. Now we're showing, again, average hours of delay for a single day. So they're now in alignment with each other, both showing average days. So the next graph I want to bring in here requires me to build one more route. I want to bring in a comparison of hours of delay, total hours of delay first here. So a bar graph summary. This is now going to show you total hours of delay for each of the years. So we're going to have to bring in our total hours of delay here. And so we have, in 2019, we have a total of 2,000 hours of delay. In 2018, it's 1,777. And back when the bridge was the old bridge, we have 8,000, and then previously even 11,000 in 2016. So, this is clearly showing a stark difference in the behavior of pre and post. We'll add this in here and take one more visualization here of the route. We can change this to show our satellite information, so we can take a closer look here at the exact sort of what the region around it looks like, etc. So just different ways that we can use the maps in these reports. And so now, just to take one more, this is the way that Chris O'Neill figured out how to really show the stark difference on this exact example here. This new route that we're going to bring in is we're going to change the data parameters of it, and this one's an important one to look at the data parameters like piece here, right? So this is sort of an advanced setup of a route, and so we're going to take this. We have a click here where it says simple. This is advanced, right? So now we have a whole bunch of tools to control this route in particular, and what we're going to do is shift how we view this route. First and foremost, we're going to take the year. We're going to give ourselves a route that starts at the very beginning of the data, right? And we're going to take it to, and this is now the very beginning of our orange route. We're going to take it to the very end of our pink route here, which is the end of 2019, December 31st. And so now this route is all time. It's going to cover every single one of the other routes across time. But instead of showing it by 5-minute epoch, which would collapse everything of that time frame down to a single day and show you the average for those epochs, we're actually going to turn this one into a graph that takes every single day from 2016 through 2019 and collapses the speed for that day down to a single number, or the travel time for that day down to a single number, or any of the measures. It will be collapsed down to a single number for that day. So it averages all of the information for a single day down to a single number. And so that's ready. We're going to hit update, and now we have 2019 to 2016 Rexford Bridge, and it's a date-oriented thing. So I'm going to remove it from this graph because it's saying that we have, in that period of time, unless you wanted to know that from 2016 to 2019 we had 23,000 hours of delay. I think it muddies up this graph. It's not a fair comparison here. So I'm going to just remove this route from here. So if you click on routes, you can come in here and just drop it like that by clicking on it. So now it's no longer showing. And we're going to add a new graph here. And this one is going to be called a route bar graph. And it's going to pop in at the bottom of the screen here. And now this one, what we're going to want to do is we're going to choose this new route that we just made, the 2019 to 2016 route. And now this one is going to show us, right now it's set to speeds, right? So we want to set this to travel time that we have. We've been setting things to travel time up here. So let's set this to travel time down here. And we can see now travel time, average travel time across for every single day from the beginning of this data set to the end, right? And we can see a clear moment where in the middle of 2017, in July of 2017, is when this bridge, the bridge project was completed and launched. So we have, there's obviously some outliers here where there's potentially a crash on the bridge or something along those lines that caused some trouble here and here. But for the most part, you're seeing a very, very big difference in speeds, right? Your average speed, or sorry, average travel time is now basically 1 minute across this with the new bridge, whereas in the past it was roughly a minute 50, minute 30, minute 50, 2 minutes, minute 50. So roughly 2 minutes versus 1 minute. So the increase of speed there is obvious. So this is one way to express the value of an updated, a change in project. And one other thing that I wanted to show too is that we could do a little bit of work if what you're wanting to do is show a potential change, like this potential change we can actually predict, or like if we think we know what the difference is going to be. Here, I'll show you one more graph that's worth bringing in here. So this is another one that's helpful here, is our route compare component. So this is a great piece for actually seeing all of the data between these various pieces. So I'm going to drop out my 2019 to 2016. We're going to compare everything to 2016. So we're going to make that our main here. So we're going to see the difference. So the comparison is 2019, 2018, and 2017. And we can see, we can add in a bunch of data. We have our travel time, we have hours of delay, we have, let's add in our free flow travel time. It's going to calculate that. So we can see just exactly how much has changed in terms of these things, right? So our average travel time, again, I was mentioning a minute 50 versus, a minute-ish here. So if we want to say 150 over one minute, or let me just get the speed actually here. So speed is 30 miles an hour divided by 20 miles an hour is 1.5. So we're looking at a change of 1.5. So what I'm going to do is show you that you could predict this with these tools a little bit here. We do have this capacity to say, let's take 2016. We're gonna make a new route. We're gonna change this to 2016, and we're going to update this. So this is going to look exactly like 2016, except now we're going to come in here and we're going to say, let's change the speed. Let's make it 1.5. So I just calculated the difference here between what we ultimately got is roughly we're roughly running at 30 miles an hour on the bridge now, when in the past we were running at 20 miles an hour. So a difference of 1.5. That 1.5 speed multiplier here, if we multiply it by that, what we'll see is how this route ends up behaving a little bit differently here. We can change it if we want to change this number around a little bit more here. 1.55, update that. We start to see that the travel time is shifting around here. So 1.75, update that. So you can see, if depending on what your prediction of how the road's going to behave, if we say so our travel time is 2 times faster, we're starting to look at a route that's behaving increasingly more like what our predicted or what our outcome was. So, if you know approximately what you think your change will do, you could show somebody what the change would ultimately result in. And you can see here that if we add this now to our route, we add this route in, which is 2016, this purple one. You can see that at exactly 2 times faster, we're roughly showing an hours of delay that's in relationship to what we ultimately got. So, we could use this tool at this point for a little bit more predictive. It's a little bit brute force. It's a multiplier, so it's not going to be completely, it treats all of the data the same way. So if there was like, the speed wasn't exactly uniform across time, where it's maybe faster during non-peak and not faster during peak, it wouldn't, you'd have to do additional work to show that, but you could potentially have shown somebody in advance that what you thought you were going to get from doing this project, and used it as part of project prioritization and advocacy.